So today we're going to look at how do you classify a number, compare numbers, work with the opposite, work with the absolute value. Again, none of these are concepts that are probably for you all that brand new. You did them once in Algebra 1, so it's not that you don't know how to do it. You may just need the refresher of how to do it. Again, just remember where I'm coming from with it. When you take a placement test or your armed services test or whatnot, most of those tests are not going to let you use a calculator. So you are strongly suggested to know how to do these concepts without the use of a calculator. That way it's not a big surprise if they tell you to do it the day of and you don't have a calculator in front of you. So let's go ahead and start with basic numbers. So every single number that exists has a classification to it. They fall in a category. So for example, when you were in pre-K, kindergarten, first grade, when you learned how to count, you started with the number 1. When you learned how to count, you started with the number 1. Those numbers are called natural numbers. It's what you naturally started counting. 1, 2, 3, 4, 5, all the way up. Now, once you put 0 in it, you have the natural numbers plus 0. Those are now whole numbers. Natural numbers are what you started counting. Once you add 0 to it, now you have whole numbers. You have natural numbers, then you have whole numbers. So we've taken care of the right-hand side of the number line. So we have all the numbers on the right-hand side of the number line. But just as you have positive numbers, you also have negative numbers. So once you bring in all the negative numbers, that's what gives you integers. That's what gives you integers. So whole numbers, natural numbers is what you started with. So natural numbers are what you started with when you were a baby. Once you bring 0 into it, then you have your whole numbers. Once you bring the negatives into it, then you have integers. Any questions so far? Right now we're just looking at how the numbers are classified. So, another way to classify numbers are rational and irrational. So, rational is another name for fraction. Any number that you can write as a fraction. Any number that you can write as a fraction is a rational number. So, 2/3 is a rational number. Why? You can write it as a fraction. 4 is a rational number because you can write it as 4/1. 0.5 is a rational number because you can write it as 5/10, which is the same thing as 1/2. So a rational number is any number you can write as a fraction. flip side to that is an irrational number. Irrational numbers mean exactly what it sounds like. It's a number that you can't write as a fraction. So you cannot write it as a fraction. So there's one particular number that I know all of you have learned at some point that is an irrational number that you use with a circle. Anybody know what that number is? You use this number with a circle. So there's one irrational number that everyone has used that you use when you're working with a circle, whether it's area or circumference. 3.14. Better known as pi. Pi is probably the most common irrational number. So they tell you that it's 3.14 just to give you an estimate. But that number can't be written as a fraction. We try to, just to make it easier on ourselves. We give you 3.14 just to make it easier for you. But pi has a whole bunch of numbers that are accurate. They actually have contests for people who can recite as many numbers for pi as possible. And there are people that have won money just for reciting as much as they could of the number pi. I've never done it because I knew I would never win. But, so pi is an irrational number because you can't write it as a fraction. Square root of 2 is an irrational number. 1.4142 and a whole bunch of numbers after it. If you can't write it as a fraction, it's irrational. Any questions on the difference between the two? Main thing you know about a rational number, natural number you can write as a number that you can write as a fraction. Number you can write as a fraction. No problem. So some of you all prepare to transition to your college life, or if you're going into work, when you're sitting in a staff meeting, you're not going to be able to probably write down word for word everything that your boss, manager, teacher, professor is telling you, but you need to make sure you get enough so that you know what it's referring to. Like I said, I don't expect you to copy down word for word what's up there. I expect you to write down enough so that you know if you go back and look at it a day from now, 2 days from now, that you know what you wrote. So, in general, if you put rational and irrational numbers together, that's what's called real numbers. That's what's called a real number. All the positive numbers, all the negative numbers, all the fractions, all the non-fractions, all the decimals. That's what's called real numbers. And this is the chart that it flows into. So, what would I ask you about this? So here's an example. If I give you the number 14, I would ask you, what are all the categories that the number 14 falls into? What are all the categories that the number 14 falls into? Now, there's one category that is automatic, and that it's a real number. So there are several other categories that it falls into. So it's a real number. Can I write 14 as a fraction? Yes, so that means it's rational. It's rational because I can write it as 14 over 1. So 14 is positive. So that makes it an integer. So since it's positive, it's not a negative number, it's a whole number. And it's not equal to 0, so that means it's a natural number. So those are all the classifications for the number 14. Those are all the classifications for the number 14. Any questions before we continue? So, I'm going to give you one to try. Seven over 5. So I will tell you that there are 2 classifications. There's 2 categories that it falls in. What are those 2 categories? My hints start all the way at the top of the chart. Start at the top of the chart. The real number. Start there. The real number. So your next question is 7 over 5, can I write 7 over 5 as a fraction? Yeah, it's already a fraction. That makes it a rational number. So here's why it's not an integer. In order to use anything below it, in order for it to be anything below, it cannot be it can't be a fraction anymore. So 7 over 5 is equal to 1.4. It has to be a clean number, like 3 or -2. It has to be a clean number. It has to be a whole number. Anybody confused with that? Yeah, 7 over 5 is not a clean number, it's a decimal. Decimal if you do like that. Now, if it was a number 7, then it becomes integer. And then 7 is not negative, so it would become a whole number. And then 7 is a natural number because you would have counted up to 7. That makes it a natural number. In order for it to be an integer, it has to be a clean number. Like a whole number. So when you see non-integer numbers, think decimal. If it's decimal, that's where it goes, and then that's it. Any other questions before we keep going? Good questions, Steve. All right. Good. Good. Below something. So in order for it to be an integer, it has to be a clean number. So a whole number. Whole number, not a fraction, not a decimal. All right, so let's practice that. Finding points on a number line. So when you graph numbers on a number line, if it's a nice clean number, then you can go ahead and put it on the graph. So for example, -5 and 1, pretty easy to put on the graph. There's your -5, and there's your 1. So I'm going to give these all labels just to make it easier. So -5 was represented by the letter B. 1 is represented by the letter B. All the other numbers up there. If they're fractions, make them decimals. Decimals are easier to graph than fractions. Decimals are easy to graph than fractions. Think about when you were in 8th grade, Algebra 1, how much you probably hated graphing a fraction. If you don't like graphing fractions, make it a decimal. So -3/2, if you divide it out, is the same thing as -1.5. So that would go between -1 and -2. One half is 0.5. Goes between 0 and 1. 23/8 is 2.875. So that's between 2 and 3. 4 1/4 is the same thing as 4.25. So it's a little bit past 4. So if you're plotting numbers on a graph, if they're not whole numbers, throw them on the graph. If they're fractions and decimals, well, if they're fractions, make them decimals. Any problems with graphing? We'll get into the real graphing later on, probably another couple of units, but you have to know how to graph on a number line before you can graph on a coordinate grid. So putting numbers in order. So if you have 4 and 9, so two positive numbers are easy to put in order. So two positive numbers. Biggest number wins. So 4 and 9, 4 is less than 9. The open mouth always points to the bigger number. If you have a positive and a negative number, positive number always wins. If you have one positive and one negative, the positive number always wins. If you have two negative numbers, the biggest number is the number closer to 0. So let me put this in terms of money. Would you rather owe someone $12 or $5? You'd rather owe them nothing. Let's put it that way. But if you're going to borrow $5 or $12, how much would you rather borrow? Why? How come I don't want to borrow 12? I'll have more money. Less than I'm gonna have to pay back. I'd rather borrow 5 than 12. So -5 is right there on the number line. -12 would be somewhere out there. -5 is closer to 0, so that means -5 is the bigger number. Now, just because someone's going to look at it and say, well, all of those were less than signs, that's a coincidence. It just so happened that the problem worked out that way. Don't expect that to work out like that all the time. As long as you know the concept, you're good to go. So, any questions before we do the last two parts? I highlighted the concept so that, it's the concept that I want you to get, not necessarily the fact that all three of those were less than. That's a coincidence. All right. Then, last two concepts are opposite and absolute value. Taking the opposite of a number and taking the absolute value. So, opposite has a technical term to it. It's called the additive inverse. Additive inverse is the same thing as opposite. So, if you see it on a homework assignment, a quiz, a test, a final, a placement test, additive inverse is just a fancy name for the word opposite. And you all know opposites. What's the opposite of a positive number? So opposite of positive is negative, and opposite of negative is what? So if I give you 2/3, the opposite is -2/3. Change the sign. +5, -5. -4, +4. What's the opposite of 0? Let's see if anyone says. No, 0 does not have an opposite. 0 is 0. It's nothing. There's no such thing as a negative 0. There's no such thing as a negative 0. 0 is 0. Period. So opposite, you're just changing the sign. Last thing is an absolute value. Absolute value is the distance between 0 and a number on a number line. So how far is a number away from 0? How far is a number away from 0? The nice part is absolute value is simply the number that you were working with. You do have to know what symbol it represents, though. So if you have 2 bars with a number inside of it, this means absolute value. That means absolute value. So for example 1, 2 inside the double bars means the absolute value of 2. So how far is 2 from 0? 2. If you had a number line, there's 2, there's 0. 1, 2. 2 spaces away. Absolute value of negative 2, same thing. 1, 2. 2 spaces away. So this note down here is very, very important. The absolute value of a number can never be negative. So the absolute value of a number can never be negative. However, depending on the problem, you could get a negative answer. Like example 3, that I just put in black. So this problem is the opposite of the absolute value of negative 5. Let's see, I just missed that. Your quiz is on. Your quiz goes live this weekend. Your unit test is next week. Next week Friday, yes. No problem. So you have the opposite of the absolute value of negative 5. So first you take the absolute value of negative 5. So what's the absolute value of negative 5? 5. So you still have a minus sign sitting out there, but now you have a 5. So that means take the opposite of 5, which is negative 5. So you're going to end up with a negative number as your answer. Now, the mistake that most people make, is that they're going to they figure, oh, 2 negatives make a positive, but that negative is inside of an absolute value. So you can't do that. If that negative is inside of an absolute value, you can't do it. You have to work out the absolute value first. All right, so let's finish off the last two. Absolute value of 8 minus 5. So you first got to do 8 minus 5. What's 8 minus 5? That's 3. So 8 minus 5 is 3. And then the absolute value of 3 is 3. Just like order of operations. Do the work inside of it, and then work your way out. Last example. So 8 minus 5 is still 3. And the absolute value of 3 is 3. So that means take the opposite of 3. What's the opposite of positive 3? That's it, problem over. So it's not a hard problem, you just have to pay attention to what you're doing. More so paying attention to what you're doing. All right. Any questions on section 9.3 before we wrap this on up? All right.